Good morning. Today we are going to see about E-plane tea and different types of teas available in microwave devices. E-plane tea. An E-plane T junction is formed by attaching a simple waveguide to the broader dimension of a rectangular waveguide which already has two ports. And we already studied about this rectangular waveguide in electromagnetic waves and waveguides. So here port 1 and 2 are collinear arms and port 3 is the side arm. So the arms of a rectangular waveguide makes two ports called collinear ports, that is port 1 and port 2, while the new one, port 3, is called side arm or E arm. This E-plane T is also called as series T. As the axis of side arm is parallel to the electric field, this junction called E-plane T junction, and this is also called voltage or series junction. The ports 1 and 2 are 180-degree out of phase with each other. The cross-sectional details of E-plane T can be understood by the following figure. So this figure shows the connection made by side arm to the bidirectional waveguide to form the parallel port. So this port 1 and 2 represents the collinear arm and port 3 represents the side arm. So the properties of E-plane T. The properties of E-plane T can be defined by its S matrix. So this is it has three ports. So it is 3 cross 3 matrix. There are three possible inputs and three possible outputs. So S is equal to matrix of there is S11, S12, S13, S21, S22, S23, S31, S32, S33. So here S11 means the input and the output. So it will be 0, right? So S11 input at port 1 and output at port 2. S13 means input at port 1 and output at port 3. Similarly for the other parameters. The scattering coefficients S13 and S23 are out of phase by 180-degree with an input port at port 3. So that means, so when applying input at port 3, and the output at port 1 and port 2 are out of phase by 180-degree. So S23 is equal to minus of S13. So this is represents the equation 2. The port is perfectly matched to the junction. So that means S33 is equal to 0. From the symmetric property, Sij equal to Sji. So we can write S12 equal to S21, S23 equal to S32, S13 equal to S31. Considering the equations 3 and 4, the S matrix can be written as S is equal to S11, S12, S13, and instead of S21, there is symmetric matrix, we can write S12 and S22 minus S13. So minus S13, S13, instead of S32, we can write S1 minus S13 and S33 is 0. So we can say that we have four unknowns considering the symmetry property. So from the unitary property, S into S star equal to I, there is a matrix with the complex conjugates that is equal to identity matrix. So here we can giving from the unitary property. So multiplying we get noting that R as a row and C as a column. So R1, row 1 and column 1. We are multiplying row 1 and column 1. So S11 into S11 star plus S12 into S12 star plus S13 into S13 star, that is equal to 1. So we can write this parameters S11 square plus modulus of S11 square plus modulus of S11 square equal to 1. So by multiplying row 2 and column 2, we can write modulus of S12 square plus modulus of S22 square plus modulus of S13 square, that is equal to 1. And multiplying the row 3 and column 3, modulus of S13 square plus modulus of S13 square is equal to 1. Row 3 and column 1, S13 into S11 star minus S13 into S12 star, that is equal to 1. So equating the equations 6 and 7, S11 equal to S22, and from equation 8, 2S13 square or S13 equal to 1 by 2. From equation 9, S13 equal to S13 into S11 star minus S12 star, or S11 equal to S12 equal to S22. Using the equations 10, 11 and 12 in the equation 6, we get S11 square plus S11 square plus 1 by 2 equal to 1, and 2S11 square equal to 1 by 2, or S11 equal to 1 by 2. S11 equal to 1 by 2. Next, substituting the values from the above equations in S matrix, we get S equal to 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2, minus 1 by root 2, 1 by root 2, minus 1 by root 2, 0. We know that from the S matrix properties, B is equal to S into A, the S matrix can be written as, so B1, B2, B3 equal to 1 by 2 and 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2, minus 1 by root 2, 1 by root 2, minus 1 by root 2, 0, with matrix A1, A2, A3. So this is the scattering matrix for E-plane T, which explains its scattering properties. That's all about E-plane T. The same process has to be followed for the H-plane T. So that also will be having 3 ports. There the T junction that is formed will be called as summa. And similarly, we will be having a magic T. So that is the combination of both E-plane T and H-plane T. There you will be having 4 ports. So you will be having a S matrix 4 cross 4 S matrix. Thank you.